Hello, welcome back to another episode of Math with Haas. You're watching Precalculus Season 2, Episode 35. We're continuing our investigation in trigonometry, and now we're going to derive the double angle identity for tangent. So, we're going to proceed similar as we have before. We can note that tangent of 2 alpha is equal to tangent of alpha plus alpha. Now, if we recall, we can use the addition formula or identity for tangent. So tangent of alpha plus beta, for example, is equal to tangent alpha plus tangent beta divided by the quantity of 1 minus tangent alpha tangent beta. So here we just have alpha plus alpha, so we have tangent alpha plus tangent alpha divided by 1 minus tangent alpha times tangent alpha. So in the numerator we have tangent alpha plus tangent alpha, that's 2 tangent alpha, and in the denominator we have tangent times tangent, so that's a 1 minus tangent squared alpha. This was another fairly straightforward derivation. And actually, it turns out we can think of this in terms of cotangents if we so wanted to. So, if we go back to our step right here, right, tangent of alpha plus alpha is equal to sine of alpha plus alpha over cosine of alpha plus alpha. Let's scratch that. 2 alpha, 2 alpha, 2 alpha. Yeah, I like that better. So tangent 2 alpha is equal to sine of 2 alpha over cosine 2 alpha. And this we know from the reciprocal identity. So tangent alpha is equal to sine over cosine. So that's the fact we're using. So let's go ahead and erase that, make it look a little neater. Alright, so with this, we know that sine of 2 alpha is just 2 sine alpha cosine alpha over, and we'll use this identity, cosine squared alpha minus sine squared alpha. And now we're going to be a little creative and multiply by a 1 over sine squared alpha over 1 minus sine squared alpha. And if we do this, yes. So if we do this, we get 2 sine alpha cosine alpha over sine squared alpha divided by, let's go with that. Took off too much. We'll have to fix that 2 now. There we go. Oh wait, no, that's a square, not a silly me. And then we have the quantity of cosine squared alpha minus sine squared alpha divided by sine squared alpha. Alright. So the first thing we can note is one of these signs is going to kill off one of the ones in the numerator. And then we need to break up that denominator a little bit. So we get 2 cosine alpha over sine alpha in the numerator. And then this becomes cosine squared alpha over sine squared alpha minus sine squared alpha over sine squared alpha. We can note the sine squared alphas kill each other off, leaving you with a 1. So we get 2 cosine alpha over sine alpha divided by cosine squared alpha over sine squared alpha minus 1. So if we note that cotangent alpha is equal to cosine alpha over sine alpha, we can now express this in terms of cotangent. So 2 cotangent alpha over cotangent squared alpha minus 1. So now we have two ways of thinking about tangent of 2 theta. One in terms of tangents, and another way in terms of cotangents. So tangent of 2 alpha, we can write it as 2 tangent alpha over 1 minus tangent squared alpha. And we could also rewrite it as 2 cotangent alpha over cotangent squared alpha minus 1. Alright, thank you for watching this video. If you've enjoyed our content, please subscribe and consider making a financial donation through Patreon. Other than that, thank you for joining our math party, and I will see you next time.